Ready, set, almost ready. Moving stuff around, almost ready. Zoom is in the way. Yeah, okay. Hello, Edward.
Hi.
Another episode today
Yeah.
about
Well,
something we get a lot of questions about, especially in early
it's a
stage when people are architecting their application. And it's a big question being SQL or no SQL. It's always an interesting topic to discuss. So let's just dive into it.
yeah. It's I already wanted to talk about this for some time now because indeed this is like a hot topic. It's a question that you often get. Like, I'm gonna build my application, and now what technologies should I use as a data layer? And indeed, NoSQL versus SQL is maybe not even the correct way to separate it because it actually you can still use NoSQL, but the determining factor is actually whether it's a distributed database or a non-distributed database. Like, do you immediately start with a distributed database, which can complicate things, or do you first start with a normal database? And what is actually a normal database? So I actually made this graph here. This is from the CAP theorem. So you always have to choose between consistency, availability, and partition tolerance. You can only choose two.
Yeah,
So you
unfortunately.
can make a database with three, then we wouldn't have this problem.
No.
So you have to choose. You can say, for example, I want consistency and availability. That's relational databases. That's like the database that we already know for a long time. So you just have like an instance. Maybe it's replicated, but you cannot write to the replicated data. You can only write to your master instance. And if the master instance goes down, then you go to the second instance, for example, the slave, the standby instance. So there's not really, your data is not partitioned, which makes it easier to think about it. You just write your data and then you get your data. You don't really have to think about the data that I just got. Is it consistent? Is it like, maybe did I do a write earlier? And then I'm getting older data. You don't really have to think about it with relational databases. And then other databases, and you can say you can have databases that are that allow for partition tolerance and are consistent, or that allow for partition tolerance and have availability. And for the purpose of today's talk, I'm just going to say, okay, these are distributed databases. You can split them up. Like DynamoDB is going to be somewhere partition tolerance and availability, and then there's other databases that are going to be consistency and partition tolerance and not that available. Probably HBase falls into that category.
Yep.
But I wouldn't really go today in that detail. It's just like, what is the difference between having to implement a database where you have a relational database? You don't really have to think about your data is going to be partitioned. You don't really have to take into account that the data that you're getting might be stale.
Yeah,
It's a
sure.
much easier way to use a database, obviously. But then you don't have the scalability instantly. Like, why would you use DynamoDB, or why would you start with DynamoDB, or why would you start with, was it on Azure Cosmos DB, or why would you start with other complex databases, Cassandra,
Yeah, that's a good one. So,
MongoDB, but MongoDB you can kind of also run, like, I don't know how MongoDB Atlas runs it, but I think you can also run it like as a relational database. But then you don't have the scalability part. So if you want to run MongoDB scalable in a cluster, then it's also more on the distributed side. When I get this question, because a lot of people I talk to are like, well, I will need to scale, so why can I not just start with DynamoDB, for example, or Cassandra or something like that? So my answer would then be, well, are you prepared to put all this time and effort into schema design, modeling of your data, modeling of the database right now instead of developing features, even though you don't know yet whether you have to really scale to 1 million users or
Exactly.
a high number. And then initially, if you don't really know how these databases work, initially you are like, it cannot be that bad, right?
No, it can.
But then you can quickly realize that you have to make a lot of decisions, and if you don't have if your data model can still change or your access pattern can still change, you have to change a lot of things of how your database is modeled.
Yeah, which it probably will, right? Who knows the exact access pattern before they start? Like that
Yeah,
would be like
yeah.
very good if you're able to identify that already. But like in
In some
reality,
cases, yes. In some cases, yes, but in most cases, no. But then, for example, one of like I know for sure Amazon.com uses DynamoDB.
Mhm.
Let's keep DynamoDB as an example. But let's say that let's say they have the Kindle app or something. There's a talk on YouTube how to architect for something like a Kindle app where you have books and you have users that buy these books from a catalog.
Yeah.
They know that this data model is not really going to change overnight.
No,
So
no,
they were really like, okay, this is our data model. We're gonna take this. Here are the indexes that we need. So one of the issues that you come into contact with very early on is if you store your data in let's say MySQL, every column you can potentially query. You can say, I need to know my data based on a certain date of birth or a certain column. Like I need to filter on this column. But in those NoSQL databases that are distributed, it's not always the case that you can just say, I need to filter on that column,
yeah,
because that
exactly.
decision you have to make up front. The decision on what columns you can filter and what columns you can get, you need to make up front because there's multiple partitions. Your data can be on multiple servers, so there's not immediately an index. And if you insert a row in a relational database, it starts building the index. You know,
Updates it. Yeah,
there's always a way to get the data.
yeah, for sure.
That's really like a massive difference. Um, yeah, this is just, I was gonna say, this is what I warn uh,
Yeah,
people that are designing the app, that I warn them for. It's like, if you're like a small team in an enterprise, um, and you say, I don't want to manage this relational database, I just need to store some data, maybe just some key value pairs, maybe a little bit more complex data, but I know I will always, to query my data, this is the starting point. This is like, I know what key I need to get. It could be a perfect match. Then use, if you're on Amazon, for example, on AWS, you use DynamoDB. There's no maintenance. You can automatically scale up, scale down, no downtime. Whereas if you would use a relational database, every time you need to increase your capacity, you actually have downtime. So it's not that easy to change like how many requests, read requests and write requests you
exactly.
are able to get.
Because like it only scales vertically. So yeah, it makes sense. SQL, like traditional SQL systems, only scale like vertically because of that gap theory. But what I also wanted to mention is that what I also like to remind people about is when they're in the POC phase or trying to build something, that they also make sure that they are familiar with the system. If you're already familiar and very good with MySQL, for example, and you're looking at DynamoDB, it can be a bit daunting
Yeah.
in the beginning, like because you don't have the access patterns, the way of how to build the queries. For example, like the lack of complex queries, you have to do it more on the application side. So like a simple example is a join query, for example. It's used a lot of times in applications, but the lack of it in tradition, like in NoSQL systems, can be a bit daunting, and then it can happen that you then have to do that on the application side, but then you have to gather so much info if your query patterns and your data patterns and your implicit schema is not built on that data, then it can become not a problem, but then you will have, like in DynamoDB, high read requests and write requests just because you're trying to get some data that you're trying to combine into one. But that's like, then you should have better chosen another system. But yeah, it's not always like that easy, because obviously you try to make the best and informed decision. But for especially if you're familiar with on like a SQL or a MySQL, whatever, Oracle, even whatever, doesn't matter. Then it's more like easier to build on a traditional SQL system, at least
Yeah.
from what I can see.
I think a lot of when people are designing systems, they're too often too much influenced, but too much influence with what they read online. Because there's a lot of blogs, YouTube videos, talks in seminars about the bleeding edge technologies, like what is new, new databases for new use cases. And they say, why should I use technology from so long ago? Because Postgres, MySQL, it's all kind of old technology, boring technology. And then I also read someone saying in like a blog post somewhere a long time ago already, probably not really on Hacker News, maybe on Hacker News, but Hacker News is more like new things.
Yeah.
They're saying like it is actually good that your architecture looks boring.
Yeah, definitely. Yeah.
Because all these fancy technologies, it takes time to not only time to learn, but it takes time. You sometimes need to hire someone. Let's say you use Cassandra. You're not on cloud, you use Cassandra. You might have to hire someone just to maintain this Cassandra cluster, just to make sure that this keeps on running, that it doesn't just go offline one day or gets somehow inconsistent. So it's not that easy. It often starts when there is actually a reason to pick another database, because a lot of data is time series now. And then time series in a relational database, that doesn't really sound like a good fit. But like, where should you then store these time series, and what database should you use for that? And is it a NoSQL database maybe better? And it might be better, but then you can have hotspotting with time series, which is something that really is a characteristic of distributed databases. So there is already a lot of things you have to think about, and I don't really always have an answer immediately whether you should really use old technology or new technology, especially when it is maybe a good fit to use one of these new technologies. But if and like that, I find a very good something to keep in mind. If you already run, let's say, a MySQL server on the cloud or not on the cloud, and you can use it, even though it's not the best match of technology, but you understand MySQL, you know how it works. You understand that the way I'm going to upload this data in MySQL, it will be all right, and the way I'm going to query it will be all right. It's not going to be the most performant way of doing it, but I will fully understand the constraints. I fully understand that it will keep on working. I fully understand what happens when the node fails. It will still continue because I have, let's say, a standby. That's often a much better way of doing it than picking a technology that you don't fully understand, just because it might be a better match, but then you have to introduce new technology.
And also finding ways to debug it, like if something goes wrong and you're very familiar with like especially performance issues. Like Percona has some good tools, for example, for MySQL, and then you just have a look at that and I'm querying this wrongly. But if you're not familiar with DynamoDB and just have really bad performance all of a sudden, and you have to type in Google how to performance tune DynamoDB, for example, then you have that's something else. And also what I also try to tell to people, it's not because you made a choice at some point. It's irreversible, right? Like at some point, because that's something that I want to ask you as well. What do you think about, for example, you start an application, it does XYZ. You start as a traditional MySQL application, or like the database is traditionally run on MySQL, but then you have a use case for NoSQL. Um, Obviously, you would just introduce like both of them, or like how
Migrate.
sorry?
Yeah, whether the question is to migrate existing data to NoSQL.
Yeah, exactly.
Yeah, I think most of the cases you will just keep the old technology. You will just run them next to each other because you often have a use case for a relational database, and then once you start growing, once you actually have this traction, you will be able to identify within the database what data is growing exponentially, maybe that you want to take out, and what data you know the access pattern of, and what data actually need to be able to scale, maybe on the fly, the underlying infrastructure to be able to accommodate for like the way that people use your application. Like, let's say you have a certain amount of users. You store the user data in MySQL, but you have something that the users generate some kind of content, and it's going to be a lot of content, and that content you want to take away from your relational database because it doesn't really fit in there. You put it in something like DynamoDB. If it's a good match, maybe even not. But you store it in NoSQL database, and now that you will scale differently. Now, what you have to pay attention for is if you have too many products, technologies, then the problem becomes, okay, if I go from hundreds to thousands users, okay, then I have this thing here, this database I have to scale, and I have this database I need to scale, and I have this layer I need to scale. So you have to be careful that there's not like 10, 20 things that you have to scale when your user base grows. And that's also a trap that a lot of companies fall in. Like, they just have so many technologies, so many different parts of the system, and then now suddenly, if a manager asks, let's say tomorrow we have 10x, we are 10x, what needs to be done?
Yeah.
And then, oh well, wait, this and this and this and this, and then you have like a 10-pager explaining just what needs to be done if you have user growth, and that's also something that you don't want. Something that might also be useful to talk about, maybe just anecdotal, like the things that we run into, maybe you with Percona. I mean, not to say that as bad technology, just as an example of the issues that we sometimes run into, that people might not think of with distributed databases, that are a bit more harder to debug. That relational databases are actually very simple. It's a very simple technology, and you might not have so many issues with it.
No, definitely, yeah, for sure.
So do you remember something of your stories with Percona, or what kind of happened, or
Like,
this is all already very far?
Yeah, luckily, not luckily, but basically, when I started my career, I worked at a bank, and then the database it was running on was Oracle. Then I switched careers to a consultancy company, and then I became an Oracle DBA. Yeah, it sounds even less exciting, but whatever. I was an Oracle DBA, and then NoSQL became. I saw a trend. Let me put it that way. So I basically proposed to the colleagues, like, we only do Oracle, so we're a consultancy company within the consultancy company. So basically provided the services to the consultancy company so they can sell it and do managed service and all that stuff. I said, like, yeah, we're a DBA team, but we only do Oracle and Microsoft SQL. Let's maybe put in catalog MySQL and MongoDB. That was the first commercial viable solution, at least from my perspective back then. And I went to conferences and stuff like that, but the whole team was like, NoSQL, like tradition. You have to, like, it was like a 55 60-year-old DBAs worked all their life with SQL and schema designing and performance tuning those schemas and all that stuff. And then all of a sudden there was a thing like NoSQL, and they were like, this is complete shit. That there's no use case for this whatsoever. It can never work. NoSQL. What is that for a question? Like they were even ridiculing it. Same with MySQL. There was like. Basically, the manager had arranged some training because there was ask for it that the team could maintain that. And then we had some training about it, and there were like literally people who were saying like, MySQL, it can't not be used for big applications. That's just impossible. And I was like, not
Facebook was using it back then. On the whole Facebook was running it.
It just came back from like a Percona had some solutions to make the operating and to work around some MySQL issues back then to be able to do live schema updates, for example. They had tooling around that, so you could do it semi-live by renaming tables, copying data and keeping it in sync, and then renaming the table. And then you could do like kind of online schemas changes and stuff like that, which were lacking back then in the MySQL versions back then. But it's only been recently updated, but whatever. And there were like people explaining how WordPress was run, like live migrating data from bigger instances to smaller instances, because when size become big, obviously you have to work around scaling issues and stuff like that. And then there were people who were like managing data from small Belgian banks, which was quite some data back then, but it's like nowhere near this scale. And then like, it's not using Oracle, it's using another technology like MySQL in that thing. But like it made it, for example, but that's more a discussion about proprietary databases versus open source. Like, for example, if you wanted to performance tune an Oracle, you had to pay for it. Like you had tables in your database, and if you queried them to get performance, you would hit a flag, and then your licensing would go up and stuff like that. So it was kind of a movement also against those things, like to put in catalog like free MySQL, just install it and it runs, and that was always good. And then then the NoSQL came, and then they were like, there's no use case for this whatsoever. And then I became a bit responsible for that within the organization. And then they said like, I think they announced it to the sales team, and that was like not a week later, there was like a big Dutch bank who was like, hey, do you guys have expertise in this NoSQL thing? Because we have a lot of financial data that we want to try to use in MongoDB. So if you guys have expertise. And then they were like, why is this not on an Oracle rack of hundreds and hundreds of thousands of euros? Because there's still solutions that were built on that, and that I saw horribly go wrong. Exactly, time series data is a good example. So there was I can't go into much into detail, but it's a project where a lot of data is involved, like kind of metering solution, and they were putting that into a Oracle Exadata, which then gets synced across the wire to another data, and then when the two Oracle data Exadatas have the copy, they confirm the commit basically. But there was so much lag, so for every meeting, for every metering, they would commit it, and then basically, it would go awire because the backlog of commits would pile up, and then everything would just break down. So that was some interesting things back then. And they never switched it to something else. And I'm like, but there's so many better solutions for this. But nobody was familiar with it. And then, kept using it. And it's like you said, now if you type into Google, you have a problem. I have this kind of data. What should I do with it? You find 100 opinions about it. And the flashiest technologies come first. But it's like you said, it's like every time you search for a solution to a problem, you will find an answer. But it will, you can end with I need a MongoDB for the user data, a Couchbase for whatever, a Redis to cache everything, and then a Cassandra for something else, and then you have like a wild growth of tools that need to be maintained. So if you can put it into one boring architecture, whatever it is, it makes life a lot easier.
Yeah, and I think we sometimes forget that on the cloud, all these things are done for you, like the whole infrastructure of what you just explained. That you would do in 2 data centers, and then the write is only acknowledged once it hits those 2 data centers. That's exactly on Amazon RDS what they do under the hood. Like you have 2 availability zones. These are two physically separated buildings. There's a write coming in. It needs to be acknowledged by both MySQLs or PostgreSQLs or MariaDBs.
Yep.
And then it is written. So you already kind of you have this out of the box. And then people sometimes ask me, why is RDS so expensive? I'm running it on an EC2 machine. And they forget these things sometimes. Like, okay, but you have all this durability and all this whole system that has been made for you that you don't have to think about. That is already done for you. You have the backups there. It sounds like a boring technology, which is a large, like an RDS instance. It's not very fancy. It's not even NoSQL. But under the hood, there's so much things happening on all cloud providers to make this work on an enterprise level that used to take so much time, that even though you still have to and manpower, even though it takes still so much, even though it takes downtime to scale, if you can live with that during out of office hours, during the night, because you can always schedule it, it's still such a kind of great solution compared to what we used to have back in the day when everything was on-prem. Before there was RDS on Amazon. Before there was like all the managed database services that now can do this offering. So we kind of shouldn't forget that we still get an enterprise solution, even though we are using some older technology, an enterprise solution that was so difficult to implement before there was cloud, because we would have 2 data centers. You would maybe run a standby just in the same rack server, even if the electricity would fall. You remember, those days. Oh, the rack, the power went down. Oh, now our secondary machine, our database is also down. And now that doesn't happen anymore that easy.
No, definitely not, because it's managed for you, away from you, basically. If you never worked in an enterprise environment or in a big consultancy companies or whatever, you're not really exposed to the real pricing of what does a MySQL on-prem cost. What is the data center, storage, networking, high availability to the other data center, air conditioning, power grid failure, backups, UPS, stuff like that. All those things, they all add up. But when people see now it's Amazon has boiled it down to a price, and it's basically enterprise technology at the price point of, how should I put it? Hobbyist technology, kind of, right? But it's hard to explain sometimes, because they say, why is this RDS exactly? Why is this so expensive? And but there's a lot of technologies involved. Yeah, but okay, there's a backup instance, but I can't even query it. Yeah, but it's not meant for it. Remember that discussion? I'm paying for it and I can't even query it.
There are solutions like with Aurora now, and that's also some of the reasons some customers pick Aurora within the AWS ecosystem. But indeed, I read that, just an opinion piece. Why are we not going back from the cloud to on-prem? Because cloud is now so expensive, prices went down, storage went down. Like, why are we just not switching back? And then indeed, like you just said, there is a lot of manpower necessary to keep these things running. Where are these people? Where are these people that can keep this all running on-prem? Well, they are now cloud engineers. They're on Azure, they're on Google Cloud, they're on AWS doing these things. There might be not so many people anymore that are qualified to maybe run without, like, okay, you still have on-prem, of course, and Kubernetes is a big player on-prem, but
for sure.
And you still have a lot of companies running everything on-prem, but like you need to also find the people again to run it like how you ran it back in the day. It's not that easy anymore.
It's very specific knowledge, because you have a storage engineer, a network engineer. It's not like the holistic thing, and those people also need to be paid. So like if you get away from the cloud, it's most of the times they what I also see that they just go to cheaper store like compute providers basically. So it's still kind of migrated away, but they don't provide any managed services like the big cloud providers do. And then obviously software. There's also a thing software, and we talked about it as well. A lot of software has become way better than it used to be. Like Ubuntu and stuff like that. Like spontaneous crashes or whatever, like those things still happen, but I think like a lot of the hardware is more reliable, software is more reliable. So it's definitely a place to do that, but that's more for very big corporations still to in order to pull that off. I still remember back in the day when we had like servers in the previous business, and then the power went out of the data center, and then you basically are so exposed to that all because then you're waiting on the power supply engineer, like the power engineer, to restore the grid or replace the fuse. I don't know what wrong, but it really shows like what can go wrong. And then if you have like redundant data centers and stuff like that, it seems all so easy. Like, well, why do they ask so much for but because they should more showcase it. And if you go through to a compliancy check or but it's also again for bigger corporations, and they start questioning where's the data stored, how you can like disaster recovery, how you can pull that off. Obviously that's not a use case for everybody, right?
You say bigger corporations, but a smaller company that grows a SaaS product or something, once you have the scale, and that's the reason why some people then pick DynamoDB and all the scalable technologies. Once you have the scale, you might get a big customer, and he's going to do a vendor assessment. He's going to ask, are you SOC 2 certified? Then SOC 2 comes into play, or maybe already earlier. Even before SOC 2, they might do some kind of vendor assessment, just like checking boxes like, are you doing everything? Is everything at rest encrypted and stuff like that? And indeed, it's so much easier to do that on a cloud provider than do this on an on-prem system, because it's just basically just clicking a button, checking a checkbox on your database to have at-rest encryption in your NoSQL or your RDS relational database. So that also helps. Indeed, that's also where the price difference comes from. Going back to relational databases versus distributed databases. So
you kind of got drifted off, but true.
There's definitely space for both of them. I mean, obviously, even on-prem, there's maybe sometimes a bigger use case to have a distributed database, because if you have to maintain a database anyways, a NoSQL distributed database might be fit your use case very well to have different nodes in different data centers, and it might be even built in the technology. I think, for example, Cassandra, like running Cassandra on-prem, there are definitely customers that we came across over the years that run this technology on-prem, very, very successful, and MongoDB as well. So to make the choice is very use case dependent, I would say, but with keeping in mind that you don't want to use every technology that's on the market. Because going back to what you said, like, okay, you have a caching layer, then you probably already have Redis. You have a relational database because you probably have relational data. You have your compute layer. You maybe have full text search with something like OpenSearch, Elasticsearch, documents that are stored in there. So you already have quite a lot of technologies, and then maybe you're gonna add a key value store, object storage. So you see the list quickly becomes big. That also means you need to know all these technologies. So I think maybe sometimes people underestimate taking out the technology, like how it can give you a peace of mind, how you can make the scope of what people have to know that are working on this architecture have to know. If you say, now you have to learn how Cassandra works, or now you don't have to learn how Cassandra works, this is a massive difference. Because
For sure.
like every company we come in, I would say there's always like, we have this technology but nobody knows anything about it, so we're not touching it.
Yeah.
And it is often a distributed database.
Hoping and praying it doesn't burn down at some point in time.
We will migrate it. We will migrate it. Not now, but at some point. I think so many companies that you came across have this issue that like must resonate with a lot of people. And you don't want to end there. If you can still make the decision, you want to try avoiding getting to a position where you're running software that you don't know how it works, that you cannot support. And I think that's why having a very basic architecture, something that's completely not sexy, can definitely help you grow as a company or a small team in an enterprise.
Yep, totally makes sense. I think that's a good advice to end the podcast for this week here at this point. If people have questions, always feel free to just post them or just let us know. We're more than happy to help out. I hope everybody enjoyed it here, and see you soon.
Yeah.
Take care.